this video lesson, we are going to cover the second part of inscribed angles and arcs, and we are also going to review for the mid-unit test. So a couple of things we are going to talk about. First is corollary 9.1. Now remember, a corollary is something that is derived directly from another postulate or theorem. So this corollary that we're going to talk about is an angle that is inscribed in a semicircle is a right angle. Okay, and this makes sense. We know this. We can derive this because of our inscribed angle theorem, which says that if an angle is inscribed inside of a circle, it is half of the central angle. So here, this is 180 degrees, right? This line, that would also make the inscribed angle 90 degrees because that would make the arc would be 180 degrees. So it's half of that, which would be 90 degrees. So that makes sense that if it's a semicircle, that the angle would be 90 degrees. So how we would go about solving one of these problems, for example, would be, say we wanted to find the value of x here, okay? Well, so in order to find x, we need to know two angles. Well, here they give us 100 degrees, and if we look, that's on arc DB, okay? And its inscribed angle is DAB. So since we know that the arc is 100, we can just take half of that. So we know that this angle is going to be 50 degrees. Well, here, angle ADB is inscribed on this semicircle right here. So what we just learned is that that is a 90-degree angle. So now we have those two angles. So we could take 90 plus 50, which is 140. And then all we have to do is take 180 minus 140, and that will give us 40 degrees. So we know x would equal 40 degrees. And that's how we would use that corollary. Corollary 9.2 says that two inscribed angles that intercept the same arc have the same measure. So what that's saying here is that, for example, angle ADB has an intercepted arc of AB right here. And angle AEB also has the same intercepted arc. Okay, so again, this corollary makes sense. We can derive this because we know that the inscribed angle is half of the intercepted arc. So no matter what this intercepted arc is, both of these angles are going to be half of that, which means they have to be equal. So here we want to find the value of x in this figure. Okay, they've given us 84 degrees and they've given us 49. Now if we look here, 49 degrees is inscribed right here in this angle. So ADB, its intercepted arc, okay, so since that's the intercepted arc, we can take 49 and multiply it by 2 to get 98. Okay, and if we look down here, angle AEB also has the same intercepted arc, which would be 98 degrees. So we know that this angle right here and this angle right here are equal to each other. So we know that angle E is 49 degrees. So now all I have to do is take 84 and add it to 49. And that's going to give us 133 degrees. And then I just have to take 133 and subtract it from 180, and that is going to give me 47 degrees. So I know that x can equal 47 degrees. Now this is just a little review for the mid-unit test. It says, given circle C with diameter AB, find the degree measure of the arc represented by x. All right, so the important information here is that we have diameter AB. Okay, so remember diameter AB, if it's a diameter, we know that that line is 180 degrees, which tells us that that arc right here, AB, is 180 degrees. So we also know that this arc on this side is also the semicircle. So we know that x is 180 degrees. This one just wants to know what is the central angle. So remember, a central angle has its two radii on the circle, and then the vertex is at the center of the circle. So here we're assuming that this is circle G. Okay, so that G would be at the center of the circle. So since G is at the center of the circle, we're looking for an angle that comes off of G to be the central angle. So that would be angle LGS would be the central angle. Here it says if angle ROW is 108 degrees, what is the measure of angle RAW? Okay, well, this is that corollary we talked about, right? If two angles are inscribed and they're with the same intercepted arc, they're going to be the same. So if you look here, ROW has the intercepted arc of RW, and RAW also has the same intercepted arc. So we also know that this is 180 degrees. Here it says name a central angle, inscribed angle, radius, and chord. Okay, so remember, central angle is here in the middle. So a central angle, if we look here, would be CAD. So we could say angle CAD is a central angle. All right, an inscribed angle has to have 2 points. All 3 points have to lie on the circle, and the vertex has to lie on the circle. So an inscribed angle here could be CBD. Okay, a radius is a line that lies on the circle, and its other point lies on the center of the circle. So here, radius could be DA. Another radius could also be CA. Okay, and then a chord is just any line that has its endpoints on the circle. So a chord, and it could be a diameter, but it doesn't have to be. So a chord here would be DB. We could also say that CB is a chord as well. Okay. Here it says find the measure of arc EB, so this arc right here, on circle C. Okay, so in order to find EB, we have to know a few things right here. First, it tells us that this is circle C. All right, so we know that AB is a diameter because remember the diameter has its endpoints on the circle and it goes through the center of the circle. So this is the diameter. So since this is the diameter, we also know it's a semicircle. That means that we know arc AEB, right? The semicircle is going to equal 180 degrees. So this whole arc is going to equal 180 degrees. So in order to find EB, it would help us to find the minor arc AE. All right, now if we look here, we know that this angle ABE is 30 degrees, and it's an inscribed angle. So we know if this is 30 degrees, right, from that our theorem earlier, the inscribed angle theorem, we know that the intercepted arc is twice that. So we can take 30 times 2, and we know that arc AE is going to equal 60 degrees. So now all we have to do, since we know AEB is 180, we just have to take 180 and we take that minus 60 and we get 120 degrees. So we know that minor arc EB is going to be 120 degrees. And that is the end of intercepted arcs part 2 and the mid-unit test review.